Alright, welcome back to the 7th video now in our series where we're covering the Unreal Engine character movement component in depth. In this video, I'm going to be implementing dashing or dodging. Really doesn't matter, just depending on what you make the animation, but yeah, it's basically going to be a short mechanic where you get a boost of velocity and then come to a halt afterward. The implementation of this isn't going to be too heavy. So last video we did a really in-depth look on proning and specifically making a really accurate movement mode. But in this video we're going to do some really light implementation, and I would say this dash mechanic is really rough. So you probably are going to want to tweak this a lot more to your system to get the exact feel that'll match your game. But I want to focus a lot more on networking stuff today, and I'm going to give you some important advice that will allow you to network your code safer and more accurately for all your movement mechanics, not just dashing. So yeah, I think this is going to be really helpful, covering some networking stuff that we haven't looked at in previous videos. So let's get right into it. So if you're familiar with my previous videos, I go through every mechanic sort of a similar fashion with the implementation, the link, and the trigger. And the implementation is where I write the code that actually implements the mechanic, so the code that actually moves the character. The link is where we make the character compatible with that movement mechanic. And the trigger is where we actually trigger the mechanic with something like a button press. And the trigger is also where the networking happens. So because this isn't a movement mode, we don't really need much linking yet, since our character movement component isn't that complex. So we're not really going to have any link, but we are going to have the implementation and the trigger. So let's start by coming down here and adding the implementation. So it's really simple for today. Like I said, not implementation heavy. We're just going to say can dash and perform dash. And those do exactly what you think they do. And then of course, before we jump right into this, we need to define some variables. So we're going to add another section of parameters here. I organized this a bit more, so the parameters are going to be the impulse we get for dashing, the dash cooldown duration, and the auth dash cooldown duration. And we'll cover how this works later, but these do exactly what you think they do. Next, we're going to add a transient variable, or I call them like working variables. Oops. This is going to be the time that the dash started at, the world time in seconds. And then I'm also going to add up at the top here a new thing. I'm going to declare a dynamic multicast delegate. Now if you don't know what delegates are, I would definitely, I'm not going to cover them here, so I would look them up in like another video. Delegates are crucial, not just the character movement component, but if you really want to maximize your C++ and Blueprints coding, I mean, you have to be using delegates, I would say. So definitely check out how those work if you don't know. I might even make a video on them, because like once I sort of started using delegates and learned how they work, they definitely made my code way cleaner. But basically, long story short, a delegate is just an event that you can create, and you can broadcast that event, and other classes or blueprints can bind to that event and receive the event broadcasts. But the key is that it's a one-way coupling. So anyone can broadcast to it, or sorry, anyone can bind to a delegate, but the actual invoker of the delegate doesn't need to know or have a reference or a coupling to the objects that are bound to it. So super useful. And then here we're basically declaring a type, and we actually are going to make a delegate of that type down here. So the syntax for this is just public, so that other C++ classes can bind to this delegate, and then blueprint assignable, so that Blueprints can assign events to this delegate. All right, now we can jump into the C++ and implement the perform dash. And like I said, pretty simple stuff here. This is the entire dash implementation. So we're going to set the start time equal to the current world time. Then we're going to get this dash direction, which this is going to be acceleration. So sorry, what this line reads is that if our acceleration is 0, then we're going to use the forward vector of the component. So basically, if you're not pressing any buttons, just use the direction you're facing in. Otherwise, if you are pressing if you're pressing like W or S or A or D, then we're going to use the acceleration, and then we're going to get the safe normal 2D, which is just the X, Y component, and normalize that. And that's going to be our dash direction. Now, I remember before I learned about acceleration, when I was just figuring out how the movement component worked, I came across this video that was showing how to implement a dash. And the guy had a server RPC from the client to the server, setting the dash direction. And then when I learned about acceleration, I learned that acceleration is also something that the client sends to the server, and it's basically just the input vector anyway. So I switched it to acceleration, and I didn't use a server RPC, but it made me uneasy because he used a server RPC, so I wasn't sure why he didn't just use acceleration. And I wanted to use acceleration for this video, but I wanted to also make sure that this wouldn't cause any problems. So I did double check, and I ran some tests where I compared the value of the input vector and the acceleration vector on the server and the client, and they're identical. So the acceleration vector that is already being sent from the client to the server on every unreliable RPC call, along with your compressed flags, that's going to be the same as the input vector. Now, the only way this would differ, and the actual reason why they have an abstraction and why they don't just call this input vector, is because technically on the client you can modify acceleration to be like, you can basically modify the input vector, and that's your acceleration if you want some custom input vector basically. And I guess I would say it allows you to have more control over kind of what the input vector is. And that just might be useful, like say you're making a movement mode where the character is only on a rail, then you want to constrain their input vector to only be like forward and backward, and we're going to call that new vector acceleration. But other than that, it's going to be identical to the input vector if you're not modifying it. So we are all fine to be using acceleration instead of having to send our own custom reliable server RPC. And I'm all for that because that saves on bandwidth, and it just makes everything a lot cleaner, less work for us as well. So yeah, I'm going to use acceleration here. All right, so we have the dash direction here. And actually, let me change this real quick. I meant to inline this like this, not have this line here. Sorry about that. So velocity is going to be equal to the dash impulse times the dash direction plus this little up component. So this line is just saying we're going to set the velocity equal to the direction times the impulse, and then we're also going to add this little vertical bump just to get us off the ground a little bit so that our friction starts a little bit later. Yeah, this is where we're actually changing velocity, and we're setting it. So we could do like a plus equals here, and this would make it more physics based because like if you already have some momentum in one direction and maybe you dash left, you're kind of going to dash like the diagonal because you're combining velocities. But I went for a more arcadey style dash here where it just kind of always is going to set your velocity to this fixed value, and you're going to dash the same distance every time. But this is up to you. So just do whatever fits your game style for like this implementation section. Right here, we're going to update the rotation so that the capsule is facing in the dash direction. Also, like not really necessary, but I think this just has a nice effect of making sure the player's facing into the dash. Makes the animation work a little better. One important note about this line, so I'm using the safe move update component. I have sweep set to false here. Now, the reason I'm doing that is because we're rotating the capsule on the z-axis. So if you think about how a capsule is shaped, rotating it on the z-axis shouldn't change the profile of the capsule at all. So there shouldn't be any way that the capsule can collide with anything if it's rotating purely on the z-axis. So I'm gonna set sweep to false because setting sweep to true has extra it's just extra computational expense. And it's not that much, but also like kind of on principle, this should never happen. So I'm setting it to false. And then I'm setting the movement mode to falling. That way we're technically in the air for like a brief couple frames, so friction isn't applied as fast. And then here we're broadcasting that dash start delegate, and this is where this is the only coupling we need to the delegate, and then anything else can bind to this and it will call those functions right here. And one really cool feature is that delegates are blocking, so all your like UI or whatever functions or whatever events that you've bound to this delegate, they'll be called immediately on this line. They won't be like in a queue processed at the end of the frame. They'll be called right here, which maybe in some cases this could hurt you, but this I think is super helpful for the state of the program. Yeah, so we broadcast that event and then we're done. Now, before I move on, I did want to say one thing about this implementation, which is that this looks a lot like the pre-built function and the character movement component that you probably all familiar with, which is launch. And I'm not using launch for 3 specific reasons. The first reason is that, this is kind of basic, but if I were to use launch, I wouldn't really even have an implementation. It would basically just be like launch. And I'm not going to do that because I want to show you how to kind of do it from scratch. But there's another reason based on my implementation, which is that I want, like I said, I want this arcade feeling launch, or arcade feeling dash, which means I want to set the velocity equal to a fixed value in a certain direction every time, whereas launch accumulates velocity. So I just didn't want that profile of impulse. And then the third and most important reason is that launch is meant to be able to be called in a non-movement safe context, such as from blueprints. Now, that actually hurts us in this case because we are in a movement safe context, or at least we will be calling this function in a movement safe context. And the way that launch is quote unquote movement safe in an unsafe context is that it doesn't immediately apply the launch. It actually creates a pending launch, and then on the next frame it will apply that launch. But we are already in the movement pipeline, so we don't want to have this execute on another frame in the future. We want it to happen right now, so that it's on the same exact frame on both the client and the server. This is weird because I actually found that in my game when I was making some mechanic that just using the default add impulse, which works the same way, it has a pending impulse, it actually causes a desync, which is really strange. It's kind of ironic that the official movement functions for add impulse or launch or add force that are supposed to be called outside of movement safe contexts actually break sometimes in movement safe contexts because they don't apply it immediately. They apply it at a later frame, which can be not the same frame on the client and the server. So yeah, I would say probably don't use launch in a movement safe context. I mean, maybe you can do it and yours works in certain circumstances, but I don't right here because just setting the velocity is a guaranteed way that it will be happening on this frame, and as long as this is in a safe context and all your input is the same, it will happen exactly the same on the client and the server. And then if you thought the implementation was simple, the can dash is even more simple. All we're saying is we can dash if we're walking and we're not crouching. I'm not doing dashing in the air. You can you know, like I said, like this is just a simple implementation, and you can look at that on your own time. But I'm just doing this simple case where you can only dash while on the ground and walking. All right, onto the trigger. So, like I promised, we're going to be using a compressed flag to trigger the dash. And that starts first by making a safe variable called wants to dash. So again, following this very consistent syntax of safe wants to dash, and then we'll come up to our saved move. And here, since we're making a new compressed flag, we're going to be reserving another spot in our compressed flags enum. So this is just indicating the name. Whoops. And here we have reserved a new name for flag dash. So 2 compressed flags down, 2 to go. Again, I don't recommend just throwing around your flags like whenever you want to make a movement mechanic. I would only reserve these for situations that you absolutely need them. And you might be thinking, well, wait a minute, you know, last video we made proning based on a server RPC plus a saved move variable. Why are you doing it differently for dashing? Because dashing is sort of like proning in the sense that, you know, at most you're only going to be able to dash like once every second or a couple seconds. The reason why I'm doing a compressed flag is there's 2 reasons. One, for it is kind of for the sake of the tutorial. Maybe if I was doing this for my game or something, this wouldn't be a compressed flag. But I do want to give you guys another reference for making compressed flags and making that work with your system. But 2, and this is more important to the actual logic of the game, is that I'm probably going to end up using this dash sort of trigger for multiple different mechanics in the game. So, like an example of this is that, like the Alt key is going to be what triggers this. So I might make it that you can also, like, if you're swimming, hold Alt to like hold your breath, or if you're climbing, maybe Alt will be like a slow climb. So I'm going to be using this as more of a general purpose trigger. And if you need any sort of input, such as like holding down a button for a certain duration of frames, you definitely need that to be a compressed flag. So it's going to be a dash for now, but you know, it might mean different things in different contexts. So that's why I'm making it a compressed flag. So yeah, we might be using this later down the line. For now, you can make it a compressed flag, or you can go based off the last video and make it a replicated function plus a saved move variable. It's up to you. But I just want to show you guys again how to use custom flags, or sorry, compressed flags. And of course, we need the actual flag itself. This is just the name of the flag. You don't even need to make this name. You can just use this value, but we're naming it to keep the convention of the character movement component. And then this is the actual value in our saved move. And of course, we need to make this compatible with all of these saved move functions. So first we're going to go to can combined with, and just like the sprint flag, we're going to add this for dashing. So we can't combine this move if the dash values are different on the current move and the new move. And go back and watch my setup and sprinting tutorial if you want to know what this function actually does. Next, we're going to go to clear, and we're going to add resetting the dash value. Now, I think I did these off camera. I think I forgot in the last tutorials to clear these other movement safe variables we made on the saved move struct. Yeah, I would obviously go back and add these. I don't think it really makes that much of a difference. The idea with clear is that you're going to reuse this save move object, so you clear the values out so that you have a clean slate again. I didn't notice any movement like desyncs or anything because of it, but obviously you do want to add these, so I just forgot about that, so that's my bad. And so now, since we're making a compressed flag, we're also going to need to add this case here. So we're going to say if we want to dash, then the result is going to add or on the dash flag. This is following the syntax again, just adding the value of the flag into the flags uint to return. So this is where we build the flags on the client to get sent to the server. And then, like all saved move values, we need to update it in set move 4 and in prep move 4. And again, watch my setup and sprinting to figure out how all these work in more detail. And then that's everything on the saved move, but we also need to go to the character and update the update from compressed flags function. This is where, so previously in get compressed flags, that's where we made the compressed flags on the client. Update from compressed flags is going to update on the server once it receives this uint of flags. So we're going to set the safe value of wants to dash equal to the value in the flags uint. Just some classic like bit packing stuff going on there. All right, so now we have a new compressed flag value that is replicated across the client and the server. And so that the state of this variable, or sorry, the state of this variable, or really I guess the state of this variable will be synced up for every frame on the client and the server. But we are not changing it. So that's the replication networking side of things. Now let's actually do sort of the client's trigger implementation. So we're going to come down to another transient value, and we're going to add this new timer handle called dash cooldown. You're going to start to get a sense of what's going on here. In the dash implementation, we're going to add a new function called on dash cooldown, probably going to be called from this timer handle. We'll implement that real quick. So very simple function. All it's doing is just setting the value of wants to dash to true. Then we need to go back to our header file and add another interface, another two interface functions, dash pressed and dash released. Again, this should be kind of no surprise here, as this is sort of the input or the link between stuff like blueprints and the outside world into our character movement component. And those are going to look like this. So what we're saying here is, and this is going to go, this might be a little tricky at first, but I'm going to explain. So dash pressed is going to set, first it's going to get a copy of the current time, and then it's going to say current time minus dash time greater than dash cooldown duration. So what this is saying is if the time that's elapsed since the dash start time is greater than the cooldown duration, then just set wants to dash to true right now. Otherwise, if we're still cooling down the dash, then we're going to set a timer for this on dash cooldown finished, which does the same thing as this, right? It just sets the dash to true. And the duration of that timer is going to be essentially the dash cooldown duration minus the current dash cooldown time. So we're going to set a timer that's going to trigger as soon as the dash cooldown finishes, and it's going to set this to true again. So this wouldn't work on its own, because this would mean that like every time you press the dash button, you're going to end up dashing, but it'll be delayed if you're on cooldown. But that doesn't make sense, because what if you let go of the dash button in the middle of that cooldown? And so that's what this function does, is this function says clear that cooldown timer handle and set wants to dash to false. So basically, if we don't release the key before the cooldown finishes, then we are going to end up dashing. But if we release that dash key in the middle of cooldown, then we are going to clear that cooldown timer. But that's not going to change the value of dash start time. So this equality will hold true whether we have the timer running or not. This timer is only for calling the setting this to true immediately when the cooldown ends. So yeah, just go over this maybe a little more in your head and make sure you understand how I'm using this timer handle. This timer handle isn't actually what's allowing us to dash or not dash. This is just a timer handle, which is allowing us to dash again once the cooldown finishes at the exact moment the cooldown finishes, provided we haven't released that dash key since we tried to initiate the dash. Alright, so now we have a variable that's completely networked, synced up on the client and the server, and we have a trigger where we're actually triggering it on the client through these interface functions, and we have a cooldown being applied to it. So it's a complete variable on cooldown triggered from a button press, but we're not using it. So that's the last final step here. So we're going to use it just like we used all our other input triggers in this update character state before movement. This is just a nice function that's called right at the start, right before every movement frame, basically, right before every physics update. So let's collapse these here and go right under prone and say that here's our dash. So first we're just going to create this reference to if we're an auth proxy. So this auth proxy basically means that we are on the server, but we are not the server's locally controlled character. So I'm just defining that as an auth proxy. I don't think that's an official definition. That's just mine. Then we're saying if we want to dash, and we can dash, then we're going to proceed. And if we are not an auth proxy, or this dash elapsed time is greater than the dash cooldown auth time, then we're going to perform the dash, and we're going to turn that dash value back to false. Otherwise, client try to cheat. So what does this mean? So here's one of the first things I want to talk about. Like I said in the beginning, I wanted to talk about some networking stuff that we haven't looked at yet. And here's the first thing, which is cheating. Because, if you've read up on your character movement component, then one of the things you're probably most excited about is this sort of immunity to cheating, because we're not using client authority and we're only trusting the server for pretty much everything. So you probably were like, sick, I don't have to worry about writing any sort of anti-cheat code at all. Now, this is the case until you purposefully implement ways in which the client can cheat. So I've done that, basically. I've implemented a way that the client can cheat. How is that? Well, we have this wants to dash, and the client it's just a replicated compressed flag. So the client can just set this to true whenever they want. Like, they don't have to respect the movement code that I wrote that will probably be rewritten on the client. They could hack the game and just set this to true every millisecond, and their goal would be that they can infinitely dash. I don't want that to happen, but we do run into a little bit of a problem here, and that is that I can't just set a cooldown timer on the server that's exactly the same as the client and just expect everything to work. And the reason for that is that time, unfortunately, passes differently on the client and the server. So if I have on the same frame, I set a timer handle, and I have the same exact duration, it's not necessarily going to end on the same movement frame. And, this is just because you're running on different computers in different parts of the world. Just many little micro nuances make up for the fact that they're not going to be the same time. And this is really annoying because it means that you virtually can't ever use delta time in any of your physics functions and expect consistent elapsed delta times, which is might be hard to understand at first, but it's just this weird phenomenon where you can't really use time in any of your movement logic and expect it to be accurate, which requires a lot of sort of finesse to work around. And actually, I've gotten a lot of comments and people asking me in other videos and stuff why are they having desyncs? Why is their client stuttering? And a lot of the times it's because they're using time somehow in a way that they can't. And I was doing this a ton, and I just couldn't figure out why. And then it hit me that there's just different delta times on the server and the client, which seems paradoxical, because you can use the same delta or different delta times, and the server and the client will still move to the same position, like in things like the fizz functions, but they're using different delta times, but like it somehow they just made it work. So like props to the guys that designed the character movement component, but that still doesn't mean that you can use the delta time in any other way. So basically, long story short, you can't just expect the elapsed time to be the same. So we need to make this auth dash cooldown duration, which is slightly less than the actual cooldown duration. And the idea is basically just that, this will capture any cheaters that try to go like 50% slower, 50% faster dash times or anything like that. But it provides a little bit of margin of error for like the client to be a little bit ahead or a little bit behind the server. But if they're going faster than zero point 0.9 seconds, then they're probably cheating. So that's what this else case is saying. And I'm just doing a tame little warning statement. You could like kick them from the game, ban their account like for a couple days. Heck, you could IP ban them and everyone in their zip code. I don't care what you do in this line, but this is just the deal with cheaters section of the code. So yeah, this is basically everything we need to do for now. And we're going to hop into the editor and check this out. But I will warn you so that I don't catch anyone off guard. We're going to be coming back and adding some code after the first test in the editor because this isn't fully complete. But I want to demonstrate something first. So let's jump into the editor and check this all out. Alright, so here we are in the editor. And before we press play, we got to do a couple things quickly to set up the character. So first, similar to previous mechanics, we're going to bind some events to the zippy character movement components events. So just grab this and say dash pressed. That's going to be on the alt pressed, dash released. There we go. Alright, and then I am going to showcase a little bit of the animations because that's the whole reason why I used those delegates. So we're going to come up to the begin play, and I'm going to grab another reference to the zippy character movement component, and we're going to do assign dash start delegate, and we'll just call this dash start. So again, the power of delegates, we can just write this, and then off of here we can do our custom stuff. So I think I'm just gonna play the animation. So we're gonna say play montage, and notice this is a character function. This is like a helper function on the character that just plays a montage. I already prepared this one. So yeah, that is the animation code. That's everything basically. Compile, save, and also take note of the parameters we got here. So we got dash impulse, we got a cooldown duration, and the auth cooldown duration. Alright, so here we are. Let's get rid of that log. So we can do everything from last time. We can crouch, we can slide, we can prone, we can sprint, and now we can dash. So it's a little maybe underwhelming. The animation's pretty ugly, and yeah, maybe I can increase the speed a little bit more. But you get the idea. It could be useful. Like you could be peeking someone around a corner, you dash back into cover. You can dash off of something. So yeah, it's that's just, there you go, like a rudimentary dash mechanic. And also, like, I think it'd sell a lot more if it had like speed lines and particle effects and other things. But yeah, that's kind of the basics. So let's show two-player here. So we have our server and our client. So I come to client, you can see I can dash, and you can see it happening on the server. And I'm not going to demonstrate with the high ping again like I did in previous videos, but at this point, you can try that on your own and just take my word for it, it works. But I do want to show you something interesting that you probably might not have expected, which is I'm going to come to the server now, and I'm going to dash, and notice it looks fine on the server, and the character is getting that speed increase on the client, but notice the animation is not playing. And that's kind of new, like that, if we go to the server and we prone, if we crouch, if we slide, all those animations are playing. What's different? What's the dash? Why is the dash not happening? So up until this point, we haven't really considered the simulated proxy at all. So the simulated proxy is a character that is on a client, not a server, and it's not the locally controlled character. So on the character here, or sorry, on the client, the server is a simulated proxy, right? You should just know this is basic Unreal Engine replication terminology. So one of the main promises, or not one of the main, but one of the big promises of the character movement component is that it automatically handles the simulated proxies really well. And we can see this, like if you look at the character here, if you look at the client on the left, the simulated proxy is moving all around and the animations are playing, everything looks great. We didn't do any of this. This is completely under the hood stuff. Even the transitions look nice. The reason for this is two things. So basically everything that goes into replicating simulated proxies is position, velocity, and movement modes. And that pretty much encompasses the entire state of what we're seeing here. So position, obviously, and rotation is just where the capsule is, and velocity is like how fast the animation is playing, and the movement mode is what animation we're playing. So all of that state gets combined, and that gives us this nice representation. But notice that no movement logic is being run on the simulated proxies. So we're not calling any functions in the movement pipeline that like do anything like taking dashes or taking key presses or replicated variables. None of the compressed flags, nothing like that is being sent to simulated proxies. Only position, velocity, and movement mode data. So if we want data about something like a dash, we need to do that ourselves. And that's something I just wanted to say because we haven't seen that up until this point. Up until this point, we've only considered the server and the owning client. But this is the first time we're going to need to consider the simulated proxies and just make sure that their state is all synced up with the state of the client, owning client, and the server. So let's jump back into the code and just sort that out. So the first thing we're going to do is we're going to make a new variable, and it's going to be a new section for all this. It's going to be replication, and this variable is going to be proxy dash start. And here I go again with another prefix. So proxy underscore is going to denote variables that are specifically designed to pertain to simulated proxies. And again, like I'm using these key prefixes like proxy and safe. I'm only ever using them when I really want you to know what their specific role is. And so these variables are the only time in our entire character movement component where we're dealing with any case that is not the owning client and the server. So these are like special variables. They're not going to be used at all by the owning client, and they're only going to have a special relationship between the server and simulated proxies. So it is going to be replicated. We're going to use rep using, so we can have this on rep function because we really only care about the animation. So we just want to play that montage when we get the on rep of this value changing. So let's go down and define this. So at the very bottom here, we're going to make the on rep definition. It needs to be a U function, otherwise it won't be picked up by the Unreal Engine reflection tool for this, or the Unreal Engine header tool to make this all work. And since this is our first replicated variable, we need to also add the get lifetime replicated props function. And I'm going to assume you already know like why we need this and how to do basic C++ replication for actors. So yeah, we're going to need to define this function. So let's hop into the C++ file and do this. So let's hop into the C++ file and do this. Yeah, so nothing too fancy. We are going to define the replication of proxy b-start, and I'm doing a conditional replication, so it's on the condition for skip owner. And the reason for this is because this only applies to simulated proxies, like I've been saying. So we don't need to replicate this to the owner. The owner already knows it dashed. In fact, the owner was the first one to know that it dashed. So we don't want this onRep to function on the owning client. Then for the actual onRep function itself, all we're doing is saying if that replicated value is true, then we're going to call that broadcast. And that's going to trigger the animation. So yeah, pretty nicely, system kind of just comes together here, I think, really well. Because, you know, again, we don't need to bind to any specific animation. We don't need to care about animation at all. We're just calling this broadcast function. And yet, by completing this, by doing the simulated, or by doing the replicated variable for simulated proxies, we've kind of made the character movement component now a closed system where every stateful data that's necessary to us has been replicated. All the movement, all the client and like server, they're all in sync, and it's this nice tight closed system. And yeah, we can still do things like access properties from it, such as delegates, to add any sort of visual effects like animations that we want without this two-way coupling. So yeah, great stuff. And then so we have this value replicated on the server and simulated proxies, but we don't actually change it. So where we're going to do that is in the update character state before movement, just like where we had our dash originally. So we're going to set the value to be true when we perform the dash. And then we're going to have an else case here where we set the value to be false. So just to real quick summarize, once we perform the dash, we're going to set this to true. And this is going to be true on the server and the owning client, but the owning client doesn't even use this value anyway. Once it's set to true on the server, at the end of the frame, the character move or just the actor component in general will like find all the values that need to be replicated. This one did change, so it's going to get replicated and sent to the client, all the proxies. And then every other frame we're going to set to false. So that's only ever set to true on the exact frame that we dash and then set back to false. This kind of peak, this like flat line and then bump every time we dash, this will get picked up by the replication system and sent to the simulated proxies, and that will trigger that broadcast, which will trigger the animation, which is the thing we wanted from the very beginning. Last thing before we jump back into the editor is we need to actually go to the zippy character, which is somewhere we haven't been in a while. And we need to add, right in the constructor, right after we get this reference to the movement component, we need to add zippy character movement component set replicated to true. So this might catch you off guard because wait a minute, was it previously not set to true? Like, why do we need to explicitly do this? Like, haven't we been like doing replicated networking stuff on the character movement component this whole time? And the answer is no. Actually, the way that Unreal Engine's system works is that we don't actually call replicated functions on the character movement component. We actually just define all the replicated functions on the base character, and the character movement component just calls those replicated functions on the character. So it's using the character's replication channel, not creating a new replication channel for the character movement component. And this is probably saving you a little bit of bandwidth. So if you wanted to, you could, for example, take this replicated variable here. Where'd it go? Here it is. And you could move this to the zippy character or your character, and that way you don't have to like create another replication channel for this object, and it can all be done on the character. I'm not going to do that because the clarity that you gain from like doing replicated variables that are pertinent to the character movement component on the character movement component is better for the sake of this tutorial. And I don't know how much it actually is going to save you, but if you're like a couple days from production or whatever, or release, and like you are trying to edge out more network optimizations and you're not going to change anything else, maybe you could go back and move all your replicated RPCs and replicated variables from the character movement component onto the character and free up another replicated actor channel or replicated object channel. Maybe I'll do that in my game. I don't even know. So I'm just not going to do it here because it doesn't make as much sense logically. So yeah, now we can finally jump back into the editor and see how this all works. One thing I should add while this is compiling is that if you wrote this line and got an error, that's because I forgot to mention that you need to include this header file. This header file is what defines that macro. So while I was recording that last bit there, I actually realized there's a more efficient way to replicate this proxy value. So previously I was setting it to true right when the dash is performed and then setting it to false afterwards. But this is actually going to cause two replications from the server to the simulated proxies for really just one event, because we have to set it to true and then we have to set it to false afterward. But that's kind of redundant. So instead, we can just set the value to be not proxy b-start. So just flipping it, and we don't need this else case. And then every time it gets flipped, it's going to trigger the replication. And then in the replication onRep function, we don't need this state anymore. We're just always going to call -start broadcast. So now the actual value of -start is kind of useless, but just the fact that it's being flipped will generate that replication and that broadcast event. So now you can see we're doing only 2 calls, and it's actually we're doing 1 call instead of 2 replication calls, and it's less code. So yeah, I had to let you guys know because I just realized that, and that's definitely, that's pretty significant, like having the number of replications you'll need for this variable. And this is probably going to be a pattern that you're going to want to reproduce. I already use this pattern actually a lot, not even just in the character movement component, but all throughout my code. Like whenever you want to call a server RPC, just an RPC, but you don't want it to be an RPC, you just want it to be a replicated. I use this a lot where I just flipping back and forth a Boolean and then getting the onRep function from it. So yeah, let's now hop into the editor and check this out. Alright, so here we are. We have the client on the left, the server on the right. And as you can see, from the client's point of view, this simulated proxy is playing the animations just fine. Yeah, everything's replicating. Yeah, it looks pretty good. Besides the animation itself, of course. So, yeah, hopefully you learned a lot about just thinking of, I guess the main thing is thinking about cheating and where you're introducing cheating with things like cooldowns and like how you let the character control RPCs, compressed flags, and their input vector, because those are like the main ways that the client controls the server. And then I hope you also started to consider how your movement logic is applying to simulated proxies. So like I mentioned, if your animation state and any other of like particle effects and whatnot are completely derived off of position, rotation, velocity, and movement mode, then those are already automatically going to be replicated from the server to the simulated proxies. But for anything custom like dashing or any other mechanics you might have, you will need to add replication to those. And I think best practice is to use a replicated variable that resides on the character movement component. So you're going to have to make that replicated. And yeah, just following that sort of pattern of proxy and then the name so that you know that this is a variable that's only pertaining to simulated proxies. So I hope that was helpful. I hope that you can like take some of this knowledge and extend it to your other movement mechanics and other movement modes, as well as even stuff we've done in the past. Maybe I don't think we've done anything yet that has allowed the player to cheat in the past videos, but yeah. In the next video, we'll probably be doing something like a new movement mode, maybe like hang gliding or wall running, or maybe like rail grinding, something like that. Or another thing I might consider doing is showing off root motion with another dash. So I might remake the dash tutorial, but with root motion, because to be honest, I think that that's like, unless your game is really physics based and you're going all for like momentum and stuff, I think root motion might be the way that more people are expecting how they want to make a dash, because you can have a lot more control. And yeah, there's certain cases where root motion makes a lot of sense. So that might be next video. I might do a new movement mode. If you have like something you really want me to cover, then just comment that, and I read every comment, so I will see it and I will add it to the list of things that I'm going to do. Like this video, as well as like several other of the last videos, have just been from you guys commenting on the videos. So yeah, I hope this helped, and I'll see you in the next video. Peace.